All right, so let's say you did on the warm-up. So if we have 7 times 7 times 7, how do we write that in exponential form, Andrew? Yeah, it's 7 to the third power. There's 3 of them. So the exponent, again, represents the number of times 7 is being multiplied by itself. 7 times 7 times 7. So the next one is 5 to the 4th power. What about the last one? What'd you get for the last one? Mind you? Yeah, 1.5 to the 6th power. Multiplying 1.5 times itself 6 times. All right? And again, going the expanded way, if we have 2 to the 7th power, you should have 2 there written 7 times. 2 times 2 times 2 times 2, and so on. Okay? And that's what the other 3 should look like. All right, so here's what I want you to do. On your graphing calculator, I want you to take these 4 values, 2 to the 0 power, 5 to the 0 power, 40 to the 0 power, and 100 to the 0 power, and tell me what you notice. Okay? So we're going to pause again here and take a few seconds, let you guys do this, and then tell me what you notice. All right, so what'd you notice? They're all 1s, right? So this was 1. That was 1. So look how they ask, how does this relate to the ballot problem that we did yesterday in 1-1? How many ballots did you have? We took a sheet of paper, we made 0 cuts. 1, right? So even though that 2 to the 0 power is 1 because we didn't start cut until we made our first cut, we had 2 ballots, right? Or until we had our first cut, we had 1 ballot, 1 sheet of paper. All right. All right, now I want you to try something here. I want you to put on your calculator 2 to the 40th power, and I want you to actually tell me what does the screen display. So if you type in 2 to the 40th power, see something that looks like that? That's a good question. What do you think the E stands for? So everybody got that, right? So what do you think the E means? E kind of stands for exponent. That number is written in what we call scientific notation. Okay? So an easier way to write this number would be and that's kind of lengthy, but we'd write it like this. Scientific notation uses base 10 numbers because that's how the decimal point moves, right? 10, 20, 30, right? Tens, hundreds, thousands, and so on, right? When you multiply things times 10, right? You get the place value system up on the wall there. So scientific notation has 2 parts to it, okay? I don't know if this will flash on or not. Okay, so the first number, this number here, has to be in a certain range for it to be scientific notation. Okay, it has to be greater than or equal to 1. We're just going to say A. Okay, and is that number that we wrote up there, is that number 1.0995, is that number greater than or equal to 1? Is it bigger than 1? Yeah. And it has to be less than, can't equal to, but less than 10. So it's got to be smaller than the 2-digit number and no smaller than 1. Greater than or equal to 1, less than 10. So that number falls within that range, right? Okay, so again, it's usually a decimal. There's your power of 10 being multiplied because, again, when we go move decimals, that's powers of 10. 10 to the first, 10 to the second, and so on. Okay, so that's what scientific notation means. So, moving down here, so if 1.25 e to the third on the calculator means this should be 1.25 times 10 to the third power, right? Which means if I take that number and they want the actual number, And I have to move 3 decimal places to the right. 1, 2, and if I put the decimal here, this becomes a 0. So that number is actually 1,250, written in scientific notation form. Because if you look at it looking backwards, wouldn't the decimal point be here? Right? So if we have 3 spots, right, to get this number to between greater than or equal to 1 but less than 10, we had to move it to where the comma was, right? That's 3 spots. That's putting a number in scientific notation. We're going to get some practice doing this today, so don't worry. Now, just the opposite. So basically, if your exponent is positive, you're talking about a big number here. Okay? If the exponent is negative, okay, because now you're basically writing this as 1.25 times 10 to the negative 3 power. Those are small. Negative exponents make the number small. So if we have 1.25, I'm trying to find the actual number. Instead of going to the right to make the number bigger, we have to go to the left to make the number smaller. So you go 1, 2, 3 places. There would be your new decimal point. So where these little gaps are would be your zeros. So that number, as you can see, is very small. So just by putting a negative sign in the exponent, look at the difference in the two numbers. 0.00125 compared to 1,250. Pretty different, right? Jamie?
So when we say like 1.523 or negative numbers, we should always write it like 1.5x.
This is just times 10 to the negative 3rd power.
Okay, so just like
yeah. And if you plug this into your calculator, if I take 10, 1.25 times 10 to the negative 3rd power, that's what it tells me. So that's how you can check it in your calculator too. Okay. And if we were to write 1.25 times 10 to the 3rd power, you can see it matches up right there. So this is kind of your introduction to scientific notation because we need it for when we start doing some of the exponential functions. But it says here you use more scientific notation in investigation 5.4. All right. So basically when you see this notation, just know what it means. And that's what this little introduction here was for. All right. Moving on over. Okay, so on the back here has our little scenario here. And let me grab a book here. This is very similar to the scenario that's in the book on page 12. I'm sorry, 10. These pages are stuck together. So it says, one day in the ancient kingdom of Monarch, a peasant saved the life of the king's daughter. The king was so grateful that he told the peasant she could have any reward she desired. The peasant, the king's chess champion, made an unusual request. So here's what she says. I would like you to place 1 ruble, and for our sake we'll just say pennies because that makes more sense to you, on the first square of my chessboard. So if I go down here to the chessboard, so we're going to put a penny here. Just think of it, so you think of it in our terms. 2 rubles on the second square. So there's 2 pennies in the second square. 4 on the third square. 8 on the fourth square. And so on. Until you have covered all 64 squares. So each square should have twice as many rubles as the previous square. So the king replied, rubles are the least valuable coin in the kingdom. And we know the pennies to be the least valuable coin in our monetary system, right? Surely you can think of a better reward, but the peasant insisted, so the king accepted her request. So did the peasant make a wise choice? Explain. So here's what I want you to do. With the pennies, I want you to fill in the table here. So remember, On square 1, there's how many pennies? Right? And then on square number 2, there are how many pennies? In square 3, there are how many pennies? Square 4, and so on. So you're going to continue to fill this in. And then, of course, what's the dollar amount? So 1 penny is worth how much? 1 cent, right? 0.01. Okay. So I want to give you guys about, I don't know, 5-7 minutes just to work on filling in the table. And if you need to, kind of help yourself by also filling the chess squares. Make sure that it stays consistent. So again, we're going to pause this video and let you guys work on filling in your table together. All right, so at 2 pennies, what's the value of 2 pennies? 2 cents, right? And we're going to write it in dollar form. 4 pennies is, and then 8 pennies is 8 cents, right? All right, so what was your next value? On the 5th square, you should have how many pennies? 16, good. So 16 cents. On the 6th square, 32. On the 7th square. On the 8th square. And 128 pennies is $1.28. 9th square, 256. On the 10th square, 512, right. Okay, so you see how we kind of started. It starts off kind of slow, right? And then it starts jumping up in a hurry, doesn't it? From a couple squares, we go from 64 cents to $5.12. So let's talk about the equation, right? What is the growth factor? How is this thing going up by? It's doubling, right? So this will be 2. And if n is the number of squares, okay, here's the thing. What square does this thing start to double? What square number does your pennies actually start doubling? No. This square, right? We went from 1 to 2. Right? Before, on the chessboard, we didn't have anything, right? You can't double 0. So when we put 1, well, then it started double. 2, then 2 doubled to 4, 4 doubled to 8, and so on. So it didn't start doubling to the 2nd square. So what happens is you can't count the 1st square in your equation because nothing doubled there. So this should be, instead of 2 to the n power, it's going to be minus 1 because you got to take away that 1st square because nothing doubled on that 1st square. It didn't double till the 2nd square. So n stands for the square number. See down the square number column? So now look at, if you plug in square 1, this is 2 to the 1 minus 1 power. What's 1 minus 1? 0. 2 to the 0 power should be 1. Square number 2, this becomes 2 to the 1st power, which is, and you see how they all line up? So now that you have your equation, we can figure out, okay, well, where's at least the 1 millionth penny? So we're going to go, I'm going to show you a little calculator shortcut here. Go to your equations. Remember we used to type equations? You can also type exponential functions. So type 2, and then we're going to hit the exponent button. And again, we don't have an n button on here, but we can just put the x for the variable, right? X minus 1, and hit enter. And now you see our table values. Don't they match yours? See that? So now when we go to table, the blue button, right? And then graph, there's our table. Well, just start scrolling down until you see 1 million. See 1 million yet? There's 100,000s. $21st square. Because that's, they're saying 6 decimal places, so that's basically 1,050,000. Okay? So what square is that? What's the x column? 21. So let me shrink this real quick. So my 21st square is when we finally hit 1 million, right? If we want to find out what the actual answer is, plug it in, right? So if it's a 21st squared, that means it's 2 to the 20th power, right? According to our equation. So that's 1,048,576. What's that in our dollar value? That's pennies. So where does the decimal point have to go? If that's number of pennies, this number here, where's the decimal point at? Where's it supposed to go for dollars? If we put that amount of pennies in dollars. Yeah, right between the 5 and the 7, right? So that would make this $10,485.76. So that's what that is in dollars. $10,485.76. Because when you have that much money, that 76 cents is really important. All right, so now they want to ask you, look at the first square, which is way up here. Let me see if I can blow this up here a little bit and see if you can see everything at the same time. All right, so the first square, let's move this down and out of the way for right now. Let's just put this up here for now. Okay, so they want you to look at this first square, right? Here's our decimal, and they want us to put it in scientific notation, right? Okay, and again, this is kind of just a little practice. So what number does the scientific notation have to be between? Look on the front side. What little range did I give you for that value? Yeah, it has to be bigger than 1, right? Or equal to, but smaller than 10. So this is 0.01, right? So where am I have to move this decimal point for it to fit in that spot? How many places? 2, right? If I move it 2 spots to here, here, I'll do this in a different color so we don't. So if I move it 2 spots to here, that's basically at 1.0, right? Okay. And since I moved it 2 spots to the right, this is a small number, right? Which means our exponent has to be negative. So if you were to write 1.0 times 10 to the negative 2 and hit enter, you would come up with 0.01 as your actual number, because we're talking about a small number, less than 1. Any numbers that are bigger than 1, they have a positive exponent. So that would be that first square if we had to write it in scientific notation. All right, now here's the fun part, right? Because the king agreed as each square is doubling, right? So before we figure out question number 64, who do you think gets the better end of this deal? The chess champion, the peasant, or the king? How many people think the peasant makes out with the more money? No? You guys think it's the king? So let's put 64 in. So again, if you put 64, 2 to the 64 minus 1 power, it's actually 2 to the what? What power? What's 64 minus 1? 63. So let's pull up our calculator. We're going to shrink this again now so we can actually see it. Okay. Here we go. So 2 to the 63rd power. Wowzers. That's a heck of a number, isn't it? So here, let's write this down. So that means 18 decimal places to the right. Well, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9 gets me to the end, right? Which means I have to add how many more zeros to that? 9. You ready for this? So this is how many pennies she gets. And then add 1, 2, 3, 4, 5, 6, 7, 8, 9. So every 3 spots, right, commas. So here, past this comma, the third comma on the bottom, you're already into the what? This is hundreds. This is hundred thousands, right? You're in the millions here. This is billions, trillions, quadrillions. You're getting into big numbers here, right? That's how many pennies you have. So now with over here, you're basically just putting a decimal point in 2 spots in, right, Nolan? Because that's what you told us just a minute ago. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your decimal point. So this is your dollar amount. She's pretty smart, isn't she? That's 92 plus quadrillion dollars. I could live with that. Could you? I don't think your several generations could spend all that money in a lifetime, let alone one. That's a lot of money. That's probably more money than Mr. King has, probably, would be my guess. So, how is 2 to the 0 power related to the story? Well, again, what would 2 to the 0 power be? The first square, right? It didn't double on the first square, right? We had to subtract that. So 2 to the 0 power is the first square. That's your starting point. And then on the graph, what do you think 2 to the 0 power is? Yep. What's also something else? Very good. It's the Y-intercept when we talk about a graph. So if we were to graph this monstrosity of a table, okay, so if I go down here, all right, so we did 10 squares, right? So we'll start here 0, and I'm just going to count to 10. 4, 5, 6, 7, 8, 9, 10. So this is our squares, which means our y-axis would be what? What's our second column here? Number of what? Yep, this is our pennies column. So if we go to 500, so let's see here. So we go by 50. So here's 100, there's 200, there's 300. Right? So now it's going to be kind of hard to see, but that 0, 1, when, on a 0 square, right? Basically your first square, 2 to the 0 power. On that first square, 1 minus 1 is 0, right? So that's where it hits the y-intercept. And then we go 2. Well, again, it doesn't start jumping up here. It's going to be kind of light here. So 2. It's almost going to look straight, but just know that it's not. Now 16, if the halfway is 50, 16's got to start to come up a little bit. 32. Now 64, that's got to be past this first line, right? And now you start to see this thing shoot up. So on the 7th square, oops, that's a 7 square. 6 square should be down here a little bit. So let's erase that guy. There we go. 8 square, we're at how much? 128, right? This past 100, I don't know, somewhere maybe right here. 256, that's 250, so, and then 512 is up here, and again, what shape is that line? It is a curve. And it continues to go up and up and up and up and up. So in the beginning, King thought he was in good shape, right? Because it takes a little time to get going. But once she basically hits about the 7th square, boom, and that's where the chess champion outsmarted the king. Not a very bright guy. Well, not really, not bright, just doesn't understand exponential and how it works. All right. So how are exponential patterns shown in a table? Okay. So when you look at an exponential pattern here in a table, that's this column right here. So how's that shown in the table? What can you tell me about that table? Think about what you've learned from linear. Does it increase, decrease? What? What does your table do? Does it increase?
Yeah.
Okay, so it increases at a, was it a constant rate of change?
No.
No. So we're going to say non-constant rate of change. Okay, now it says how are patterns shown in the graph? Well, again, if we go from left to right, right? If we go from left to right, it increases slowly before, usually near the end of the graph, it starts to shoot up, right? So again, we could just say basically almost the same thing as we did in the first one. So it increases from left to right at a non-constant rate of change, at a no crack, right? This line is a curve. It's not a straight line. It's a curve. So how are they shown in the equation? Well, remember, I showed you the general equation yesterday. So we're going to write the general equation down, right? Okay. And you can find it right here. It's that number that's in front of the exponent. It's that base, right? Remember we called it the base or the growth factor, right? The base. It's that base. Number in front of the x, the variable, the exponent, the x. Again, now Jamie said, what is a zero? What does an exponent of zero mean? Well, we know an exponent of zero is one, right? So we'll just say, let's say 2 to the 0. We know that's 1, right? So on a graph, it's the y-intercept. That starting point, okay? When you get a 2 to the 0, that equals 1. That's usually your starting point. This line as a curve, remember when we did inverse variation, that has a curve, right? A curve that looks almost similar to what exponential is, right? But what's the biggest difference between exponential and inverse? Exponential actually touches the y-axis, right? Remember, inverse didn't, right? Remember in inverse, we had something like this, right? And it would come down, but it would never touch, right? Well, an exponential actually goes right through. So they both have curves, but one will go through the axis where the other one doesn't. That's the biggest difference between those two. How are very large numbers shown on a calculator? What happened when you type that very large number in, right? We got that E. What was that called? Exponent, but what's the word for it? Scientific notation. Scientific notation. So when you see that E, that number is written in scientific notation. So if you have a positive number past the E, you got to move the decimal point over to the right, right, to make the number bigger. Okay, it's negative, right? Just that little thing we did. All right, so that's the video. So I'm going to pause this for right now. All right, and here is your homework. Now, I'm going to kind of explain. Now, we're not going to check this till when? Monday. Good. You guys are sharp as a tack. Because most of us are going to be gone, including me, till Monday. So this is when we'll check it on Monday. For the people staying back, there is some, Mrs. Demura put together some stuff for people to do. You'll have specials. It'll be like a normal day. Oh,